Application of chain rule. Determine the coordinates of points at which curves y equals to 3 minus x cube whole square and y equals to minus 2x to the power of 6 have the same slope. Now here, one curve is y equals to 3 minus x cube whole square. Here we can apply chain rule, right? And this is the normal power function where we'll use the power rule to find the derivative. Now when we say they have the same slope, that means the derivatives are same, right? So we'll equate the derivatives to same and then figure out what x value is. And we can get more than one point in this case, correct? That's why we have points here. So let's try to do with both the functions. First with y equals to 3 minus x cube whole square, right? So what is y dash? Y dash is 2 times 3 minus x cube times derivative of minus x cube, which is minus 3x squared, right? That's the chain rule. Now that's the derivative, and we'll call this equation as equation 1. Now for this equation, which is y equals to minus 2x cube, let's find the derivative. So y equals to minus 2x to the power of 6 in this case. So y dash is minus 12x to the power of 5. So that's the slope at any given point on equation number 2, right? So that curve will have the slope. Now since we have the same slopes, so 1 and 2 should be same, right? So we'll equate them. So we get what? So we get from 1, minus 3 times 2 is minus 6x squared. So let me rewrite this, right? So we get minus 6 x squared times 3 minus x cubed equals to minus 12 x to the power of 5. Right? I've seen in test papers that at this stage many students will cancel out x squares and then solve further. Well, if you cancel out at this stage, then you are actually cancelling out one of the common points. So that will be a huge mistake, right? So don't ever do that. So the strategy here should be to bring them together to one side and then solve, right? So what I'm trying to say here is, when you have to solve this equation, then you open the brackets and bring them together, right? That is how you should be solving. So we'll bring them here. So minus 12 x to the power of 5 comes on this side. So we get 12 x to the power of 5, and we have a minus 6x squared 3 minus x cubed equals to 0. You see, I could have expanded this and then done, but here we have an advantage. We have a common factor of 6x squared, and therefore there is no point in expanding this particular expression, right? So that is why we're just keeping it like this. You'll appreciate it soon. Now from here, this equation, we can take 6x squared common, right? So we'll take 6x squared common, and then we get from here 2x cubed, right? Minus, within bracket, 3 minus x cubed. Do you see that? So there was no point in expanding this expression at this stage, right? We could have got the same result, but you understand. Let's simplify this a bit. So we get 2x cubed minus and minus x cubed becomes plus x cubed, right? So we get 3x cubed here minus 3 equals to 0. Now this equation will be 0 if x is equal to 0 from here. So we can get x equals to 0, or from here x is equals to 1, x equals to 1. So these are the two x values of the coordinate points which will ensure that the slopes are same, right? Let's also try to analyze, if x is 0, what is the slope? So we can check with any of these equations. This one seems to be simpler to check. If x is 0, then the slope should be, if I put 0 here, then in that case y dash is 0. Do you see? It's a horizontal line. And if x is 1, then y dash is equals to minus 12, right? Minus 12. So these are two different slopes, right? If the slope is 0, then we have x equals to 0 as the point. If the slope on both the curves is minus 12, then x equals to 1 is the point. Is that okay? That is how it is. Now, as you know, we have two different equations, right? So our equations are, one is y equals to minus 2x to the power of 6, and the other one is y equals to 3 minus x cubed whole square. Now for x equals to 0, what are the points? So you plug in 0 here, so the points will be coordinate points on this curve at x equals to 0 will be, if I write 0 here, 3 square is 9, right? And if I write 1 here, then the point will be 3 minus 1, which is 2, 2 square, which is 4. So these are the coordinate points on the curve y equals to 3 minus x cubed whole square for x equals to 0, right? So I'm saying x equals to 0, and this one is for x equals to 1, as you can see, right? Now for the other line, if we put x equals to 0, then we get coordinate points as 0, 0, right? And if I put x as 1, I get this as minus 2. So these are the coordinate points on the second function, right? Now as you can see, whether the point, these are the points, let me write what are their derivatives, which are same. So y dash, which is the derivative, if I put 0, then the derivative will be 0. If I put 1, derivative will be minus 12, right? So this form we can write down very clearly our answer, right? So that is right there, our answer. We say the coordinate points are this set of points on the first curve and these set of points on the second curve. Or we can write at x equals to 0 and at x equals to 1, correct? On both the curves. So that is how we can solve this question. I hope it makes some sense to you and you like kind of way it has been done and neatly laid out. So that ways you should solve these problems. And remember, same slope means same derivative, correct? Thank you.